In this video, we will learn about some hardware details of the RTL. This is the general architecture of this device. You can see that we have two parts, the analog one on the left and the digital one. In the analog part, you have the radio frequency part and the intermediate frequency. The analog to digital conversion is done in this intermediate frequency, and then we move to the baseband. So we will have two frequency conversions. If you look in more detail to this diagram, you will see that the first step is a low noise amplifier. Its objective is to amplify the signal, introducing as less noise as possible. Also, you will need to suppress some certain bands in order to avoid some undesired frequencies to get into the system after the first frequency conversion. This was explained with more or less detail in the first module of this course. After this conversion, we are now in intermediate frequency, you filter again the signal, you control the signal strength with the gain control, which is one of the parameters that you can control in this device. And then you go to the analog to digital stage. Before this stage, you also need to filter the signal. This is called the anti-alias filter. And then you will have, after this analog to digital conversion, you will have two branches, the quadrature and the in-phase branch. These two branches are very similar. The signal suffers another frequency conversion, in this time from intermediate frequency to baseband, and the signal is resampled and synchronized again. It's decimated, and then the output goes to the USB port at the desired frequency, at the desired sampled frequency. This is a summary of what we have explained before. A very important parameter is these 8 bits for both the in-phase and quadrature branches, and also the sampling frequency. This is the RTL open. The first component is the USB interface. We will plug the RTL here to our PC. Also, it has an EPROM where the software or the firmware is loaded. This is the antenna port, so here we will plug the antenna. Also, it has an infrared sensor, but it's only used in the TV mode, so here in the test mode or in the general mode we won't use it. Here you have a diode to protect the circuit from electroshock. Here you have a power LED to let you know that the device is powered. Here is the tuner. From here you obtain the clock signal, very important in communications for synchronization purpose. And here you have the modulator. This is the nano version of this RTL, which all the same elements as before, but here as you can see, in less space. And this is a summary of all the features that we commented before. In this diagram that looks very complicated is shown everything that happens to the signal since it's received in the antenna port and its end when it's delivered to the USB port. So the first thing that you need to know is that there are three different frequencies. The first one in the right, it's the radio frequency. This is the frequency that it's transmitted. Now the process is done from right to left. Then we move to intermediate frequency, which is, you have the same signal. You can see that the shape of this signal is the same here, here, and here. You only change the frequency. Here is baseband, here is the intermediate frequency, and here is radio frequency, but it's always the same. And the steps are the one that we mentioned before. Here you can see also which functions are done by which component of the RTL. All this part is done by the Rafael micro, the tuner, and all this part, all these stages here are done by the modulator. This is the digital part. Of course, this output goes to the PC. Some details about these frequency conversions. The intermediate frequency in this device is 3.57 megahertz. We can fix, of course, the radio frequency of the circuit. So, if we have an intermediate frequency fixed and we need to change this depending on the application that we have, the RTL will change the frequency of the local oscillator to have the proper frequency. Now let's go to the sampling and decimation. As we mentioned in the previous video, this is one of the parameters that we can choose. And we said that the maximum frequency, sampling frequency that we can have, it's 2.8 megahertz. But actually what the RTL or the ADC of the RTL does is to sample the signal at 28.8 megahertz. This is 10 times the maximum frequency that we can have. And then it decimates the signal with a factor, with an M factor, to obtain the final sampling rate. So for example, if we want a sampling frequency of 2.4 megahertz, we will have to decimate with an M factor equal to 12. So if we divide 28.8 by 12, we will have the desired sampling frequency of 2.4 megahertz. And remember always the Nyquist theorem, where you need to sample at a rate twice the bandwidth of the signal. And that's it for the moment. Thank you very much.